slope fields. We dealt with a little bit of them last year.
What?
Um, I will teach you how to do them on your calculator. I should get that app open while we're doing this. Okay. Unfortunately, though, I have to turn that feature off on your calculator for the exam. Is it you don't care, you're not taking it. Yeah, there's a few. She will learn all the well, she did the dual credit calculus last year, and you're not really supposed to do both. Why? You're not supposed to try to get credit in two ways for the same thing. So, yeah, mostly what you're here to do is learn how to do everything, so you've been introduced to everything when you have to do it in college. Because they don't really let you out of much for this. So here we've got slope fields. Yes. Okay. So we're gonna go a little bit deeper with them, not a ton. Okay? Who likes the idea of not a ton?
Yeah.
Um, yeah, we're into Calc 4. This is all the beginning stuff. We're not going crazy deep. Okay? There's a few things that are a little bit like, what? But that's coming Thursday and next week. Okay, so we have a differential equation. What's a differential equation? What's a differential? A derivative. Usually, a differential equation includes a derivative or a dy dx in the equation somehow. Usually, they are in the form like this. Y prime or dy dx equals. Remember, y prime is dy dx. Okay. A slope field also, a direction field can be given. So we're going to look at this differential equation. You want to know how to graph that on your calculator?
No.
Would you rather do it by hand? I mean, what you can do is you can plug in and you can get the slope at the point. Let's do the point 1, 1. What's the slope? So this is easy. The point 1, 1, what's the slope? I plug in x and y, 1 and 1. It's a slope of 1. The point 2, 1, what's the slope? 2. What's 1, 2? 2, 2 is 4. That makes sense?
It's that. It's still.
There's It's at that point, so it's changed. You know, when I get to 1.5, 1.5, it's different. It's 2.25 because 1.5 times 1.5 is 2.25. All of these on the axes are zero, aren't they? So you can generate a very small slope field by hand. It's tedious. Hopefully they wouldn't give you. I've never seen an exam question where they actually make you generate a slope field by hand. I have seen some where they'll make you sketch something and you'd want to come up with like four of them. Okay. Not make the entire thing, but maybe make, okay, where's across the X and Y axes? Get those slopes. Okay. There is a question on your exam where you will need to do that. This next exam will be heavily curved.
It's hard though. No, but.
Yeah, there are questions that are on there that you need to see at some point, and that's the best way for me to get you to take them seriously. And you will make corrections. Like plenty.
The hundred?
50%? Not quite that high. So no, I'm gonna make you do corrections, but a 75 after corrections is a 6. A 7, you might need to get 80 after corrections to get to 80%. Yeah, to get a 7. Yes. Does that make sense on the slope field? Now let's show you how to make it on the Inspire, because it will do it for you. And as you're doing these and you're doing the review problems, if a slope field's helpful, make sure you can make that basic thing. But don't take the time, because I'm going to give you too many questions. You need more practice than I can give you. So we're going to add a calculator. And you guys haven't done much of these, have you? Did we do relation? I don't think we've done parametric or polar in this class. So the bottom one here is differential equation. So what this is y1 prime. Okay, there's a trick to this. I just type it in. X times, I cannot use just y. If I hit y, nothing. I need to hit y1, referencing which y I'm choosing. So this needs to be y1. Okay?
Oh, shoot.
Menu, graph entry, edit, differential equation. Okay. Kind of nice. That made by direction field, didn't it? So my differential equation was this. I'll write it on here. I had dy dx equals xy. So I put in the box x times, I did y1 because the y I'm referencing is the y1 equation. Because you can have multiple differential equations. I'm not sure why I would want to put multiple on the same graph, but you could. Well, the thing I haven't showed you yet is I can put in a point to sketch it through. Oops. 2, 1. Remember making different sketches through different things? Where this could be useful, I suppose, is I could do x times y2 and make another point. It didn't sketch that. Why did it not sketch that? Oh, still didn't sketch it. I don't know. I've never tried to have it make two of them before. I did. And then it still does, it just unchecked it. So, but we could make lots of sketches of parallel things by changing the point, right? I think it would be a mess to put multiple direction fields on top of each other, and that might be why it's objecting. Does that make sense how to do that? You just have to choose differential equation and use it. So here we have a direction field. Let's say I went through the point 0, 1. So it looks like it's going horizontally and then curving up and getting pretty steep, right? Looks a lot like a regular quadratic. If I was down here, where would it go? Looks like it's going down, right? If I did one really close to the axes here, it still eventually gets steep, right? So depending on my initial point, I can have, they're similar graphs, but they're different, right? Depending on, there are some slope fields that are a lot more dissimilar depending on the point. Okay? So your exam tip is you can use all the online tools in your calculator in the test class, but you can't use it in there. So draw the slope field using a grid, point with integer coefficients -4 to 4 and -2 to 2. So let's just start with points like, let's do a couple of points and then we're going to just, I'm going to show you the answer. Let's do 0, 0. Well, I've got 0 times something, so that's 0, right? That's pretty common in these. 0, 1. -1 times 1 plus 0 times 1 over 1 minus 0 times 1. That's -1. Anything with a y being 0 has this 0 at the beginning, right? So that's 0 times something. Thanks. Do you guys understand what I'm doing here?
No, thank you.
I'm plugging the points into this equation.
No, which ones?
Each one.
Zero.
Now I'm at 2, 1.
I'm trying to find a solution.
This will be, and then getting a slope. So that's -1. The top is 3, the bottom is -1. So m equals 3. Does that make sense? Um, if you get undefined, what does that mean about a slope? So if you get a zero vertical, so 1, 1 should be undefined, I guess, because I got a vertical slope there. 1, -1 is. So yes, that would be tedious, wouldn't it? Not ridiculously hard, but tedious. It's a very long, complicated, middle school math problem. Plug in for X and Y, but you have to do 8, 9, 9 by 5, 45 points.
And wait, we're gonna have to by hand, like, matching on the sticks.
Yeah, I'd want you to do something like 4 and use your calculator for the rest. but I want you to practice a few of them so just so you know if it comes up on the exam and you have the time to do it, do it. If it doesn't come up or if it comes on the up on the exam, at least do some of it. Yeah, so you can get some of the points and go, you could write ran out of time if you run out of time, ran out of time to finish. I have yet to see one where they're like draw the direction field. Okay, using the slope field above, it says sketch the thing with initial condition y0 equals 2. What's my coordinates there? And then y0 equals -1. So 0, 2, and 0, -1, right?
Well, what do
There's a second one. There's two of them. And I started scrolling back up as soon as I saw it. And you guys were telling me that. 0, 2, 0. Oh, let's do a different color for 0, -1. So you definitely need to be able to do this. So 0, 2, I'm here, going down, getting steeper, and it appears to be coming down there and following along the axis, right? As I go this way, it appears to kind of level off and come back down somewhere around here, maybe? Does that kind of make sense what I'm doing? Just kind of following the paths of the slope. 0, -1. So it looks like it gets real steep here. And then it does look like it's going to start curving down. Looks pretty flat here, but it looks like it eventually starts to curve down some way, somehow. Let's see how mine match up with theirs. Pretty well, actually. I'm getting good at this. Draw more solution curves. I'm just going to show you that.
you?
They picked a whole ton of different points, right? So, depending on which point you go through, you're going to sketch any of those. If you could incorporate math into some of your art, yeah, like that would be kind of cool connection. You potentially, if you used a slope field to make art in a math IA, I don't sure you guys want to start over again, but
Holy crap, it's like that one thing you do with the graphs, but like way more miserable. It's less project.
the Desmos project, I don't know, Rowan's might have taken the cake on that. It was crazy. So, so here we have 2xy. Passes through the point 1, 1, sketch the solution curve. Okay. 1, 1. Looks like it's going pretty steep here. Leveling off, and looks like it's mirroring. Looks like a quadratic. Absolutely. And yes, voila. I did look at these last week. But I'm also going, I don't exactly remember, but I'm like, oh yeah, that seems like it would be like something I've seen. So, isoclines. Isoclines aren't actually on the exam, although understanding them, I think, will help you with slope fields and with phase diagrams, which are coming. Okay. Which I have yet to see a phase diagram in one of the actual exams. So I right now have five legitimate IB exams, and I have the ones they took last year. I need to figure out which version of the three versions that I have, but they got us the ones from last year. The exams?
Yeah.
Yeah. They switch it every time. So that I think there's three papers, but I think there's three versions of each paper. Like so that, so no, everybody here had the same one because I got to review I had to review it, but yeah, they could give the time zone that would potentially get out right as you're taking it a different paper. So it makes it really hard to like give people because people were a couple years ago and they might have just started that last year. But they made everybody stay in the room longer and because people from Europe were telling the answers to people in America over Facebook and things. Yeah, people were posting questions and so it made it unfair. So, but I don't know where they were, but it probably wasn't Facebook, let's be honest. You guys are teenagers. It was Discord.
This four of these.
Um,
No.
so I haven't looked at all the versions, but last year their differential equations questions weren't that bad. They were also in paper one, not paper 2023. There was one in paper three. So a differential equation was half of that paper. Now keep in mind the tests are all curved. So most people probably got 3 points out of the 20 some on that problem. 3 to 5 points, which means it's just curved more. So an isocline is a curve connecting all points on a slope field with equal slopes. Okay? So this left one here is a curve going through all the spots with slope 0. This one I think is all with slope 1. It is a curve connecting all the points with equal slope. Oh yeah, it is. They're using C to represent slope in this situation. Does that kind of make sense? So it's a different way of thinking about essentially the same thing. These the, once you get some of these drawings look like you're like, what? But they look really cool. With what?
Yeah.
Oh, for sure. Um, so we're gonna sketch this solution curve for the differential equation that starts at point 0, 1 and crosses the isocline corresponding to c equals 0 and reaches the corresponding isocline at c equals 1. So here's my two isoclines. It starts here. If 1 is here and 0 is here, this would probably be in the negatives, right? It needs to reach, needs to be zero when it goes through this point, and one when it goes through that point. So it's probably negative here. It's going down, coming down towards zero. And it's going from zero to one. So if this is slope zero, this is slope one, you could, it, because then this would, the isocline would have to go through here. There's got to be another isocline here for negative one. And it's one, zero. There should be one for negative one. Oh, okay. It does say, oh, you plug it in and you get the gradient there. That's how they did that. So they literally plugged it into the dy dx to get the starting
Start.
the starting gradient.
We didn't mention.
No,
Is that?
this is Diffie Q, Calc 4. You don't stay on engineering if you don't want to do this. It's not as if you work your way up to it, like this would have seemed awful to you guys 2 years a year ago doing the calculus.
It seemed awful. That.
Would have seemed more awful.
Yeah. Oh.
Like you're pulling it off. It's hard. Okay, use isoclines to make, so now they're making curve defined on, so now they're giving you more isoclines. Okay, we'll watch that video after, but here you've got more of them. They want us to go through 0, 1 again. Oh, this is the gnarly one. Okay. I'm gonna do a different color. So we know it goes down. It's negative 1 here. It's got to get to 0 here. It's got to come to 1. That's the part. It's the same equation we just did. Now it's got to get steeper to 2, 3, 4. So it's negative 1 here, right? It's still negative 1.
Like.
It's got to go through, it can't go through 0 unless it's horizontal. So it's got to stay in between 0 and 1. Yes, I did look at this in advance. So does it make sense the negative 1 here? We start with the slope of negative 1. It's headed towards 0, so it's got to decrease until we have a slope of 0 here. Slope of negative 1, slope of 1 here, slope of 2 here, slope of 3, slope of 4. This part is the hard part because we never actually get to negative 2. Our slope of negative 1 carries us back up into the negative 1 line. It would get slightly steeper because you're between negative 1 and negative 2. But essentially, it carries you back up. And then we have to be horizontal by the time we hit this 0. So we're never going to hit that 0 because it's not a horizontal line. That makes sense? So it gets trapped between the negative 1 and the 0. And they would, I'm pretty sure, give full credit for my rough sketch there. Okay. That kind of makes sense. You just have to figure out the curves. And yes, this is not on the exam. Doing a few of them and trying them will help you. I got a little steep, a little fast, looks like. but I'm pretty sure that's close enough. Okay. Here, the colors are all the isoclines. That makes sense. So isoclines are simply connecting spots in a slope field with equal slopes. Okay?